Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event, in which we are once again going to dive into the hottest topic out there in the field of information management. Yes, it's all about big data again. In fact, today we're going to take a close look at very big data and very big databases and how we can deal with all these new forms of data and just these amounts and the velocity and so forth. So there's a slide about yours truly, and enough about me. So the mission, as many of you now know here in the briefing room, is really to reveal the essential characteristics of enterprise software. So what we do is we take analysts and we pair them with innovative vendors, and the key is that the analyst and vendor do not coordinate before the call. And the reason is we want to expose the kind of organic conversation that you'll get between a vendor and an analyst when that analyst is taking a briefing on what is new and exciting. So that's the whole purpose of the show, and it allows you as an audience member to kind of peer over the shoulder of the analyst as he or she pokes around in underneath the hood of the technology to figure out what it does, how it works, why it was designed a certain way, and really what those critical nuances are to the technology. Because as you know, when you're about to purchase some new enterprise technology, it's a very serious decision. And that actually leads me to my next slide. October is Database Month, and the reason we do different topics each month is because we're trying to give our audience members some good apples-to-apples comparisons of various technologies out there in the field today. And obviously, database, goodness gracious, there is so much activity in the database field these days, it's almost hard to believe. But when you think about what's happening, it makes sense, right? So you have this explosion of data on the internet, and of course you've got big companies like Yahoo and Google and Facebook and Twitter and LinkedIn and all these web-based properties who really had to go out and design, some of them, new technologies to deal with the raw amount of data and with the workloads that they were facing. It's a very different world out there than it was just 10 years ago. And one of my personal theories is that the recession back in 2008, the financial meltdown, led to a resurgence or at least a surge in activity and investment for open source technologies. So we've seen this whole Hadoop world just blow up. Every major vendor that we cover in this space is talking about Hadoop these days, and obviously that means it's here to stay, or it's at least here to stay for a significant period of time. And it does change the landscape, but it's not the only thing out there, of course. There still are all these closed source vendors, and they've been working diligently to keep up with the times. And what we're going to talk about today is how some of these database technologies can handle the volume, the velocity, the variety, all these critical workloads that are, let's face it, facing many large organizations today. So we're going to talk about some of the ways that database technology can be blended, essentially, to leverage the power of all this new stuff, this big data, but also mix and match it with your structured data that we all know and love. So the whole world of SQL and NoSQL. The analyst today is Robin Bloor, our very own Robin Bloor, namesake of the company here, my good partner. SAP, of course, as many of you know, is a German-founded software company. It is huge. Of course, they bought a number of different companies in the recent years. They have the Business Warehouse, they have Business Objects, and of course Sybase, and that's what we're going to be talking about today, is some of the legacy Sybase stuff that has been improved over the last year or so. Our presenter is going to be Courtney Claussen. She's a product manager at Sybase, concentrating on Sybase's data warehousing and analytics products. And with that, I'm going to push her first slide, and Courtney, I'm going to hand you the keys to the WebEx. And that's it. So just click anywhere on that slide and use the down arrow to move the slides, and the floor is yours.
Well, thank you very much, Eric. It's a pleasure to be here today. You know, now that analyzing data in real time and extracting value from data structures such as text is conceivable, organizations are recognizing the need to extend the capabilities of the traditional data warehouse. Businesses are augmenting their infrastructures with technologies to match the kinds of data they're working with. Some terms for this are the logical data warehouse or hybrid data ecosystem. We're going to discuss the realities of big data analytics today, why it requires a new kind of platform, and how SAP Sybase IQ is stepping up to the challenges of massive data volume, variety, and velocity. We're all hearing a lot about big data these days, huge volumes of data generated at high velocity by social media, web traffic, sensors, other sources. But big data is not just the latest buzzword. Real changes are happening in the business world. Data-driven analytics is making a measurable impact on businesses, from operations to revenue generation to coming up with new strategic directions. This has been proven out in various studies. For example, a McKinsey study has determined that companies that have adopted data-driven analytics have seen a significant return on investment. The study examined various verticals from retail to healthcare to government, and the numbers are really impressive. 8% reduction in U.S. national healthcare expenditures, $150 million savings in government operations in Europe, and a whopping 60% improvement in retail operating margins. Now, big data analytics is becoming a powerful business tool that's being used to unlock data from value from data and make it more useful in key business decisions and processes. For example, financial companies are able to analyze big data from different angles, view trends, perform simulations to predict future performance. Insurance companies are using analytics to see patterns in billions of claims and identify the few that are fraudulent. Analysis of shopping and sales data gives retailers the confidence that they have the right products in stock to meet the demand, and many other use cases. Big data differs from traditional transactional data in a number of different ways. First, there's a lot more of it, so there's an even greater volume and storage issue. Second, big data consists of raw data that has not been processed by a transactional system before it's moved into the data warehouse. It's generated and processed directly. And because of the volume, there's no time to evaluate or transform it before it is processed. Third, big data is not intrinsically relational. Some of the more structured data, for example, data that from smart meters of log data, can be put into relational format, but unstructured data, blogs and tweets, for example, is less amenable to these transformations. And fourth, most big data application logic will be developed using the MapReduce framework. This requires skills and procedural languages. The query and analysis of relational data uses declarative SQL. Fifth, Hadoop has been designed to run batch-based queries and is not generally suitable for real-time query processing. And finally, traditional data warehouses tend to scale up. You have a single system to which you add more hardware. This has advantages for performance and fault tolerance, but with the sheer volume of big data, this is not really practical from a cost perspective. It's necessary to scale out, adding more small, inexpensive servers rather than extending a single large system. Now, we don't suggest that you run all of your analytics inside Hadoop, but because of the costs involved, it's really not practical to put all of your data in the data warehouse either. We must consider how a traditional data warehouse can work alongside a big data processing environment in a hybrid deployment. Now, by integrating your warehouse with Hadoop, you can realize some key benefits. You combine and process all relevant data. Some of it's residing in Hadoop and some in IQ. And you can augment Hadoop with real-time business intelligence and analytics. This requires only a single copy of data that is shared between IQ and Hadoop, resulting in lowered storage costs. And you can use standard SQL for querying data from Hadoop, just like you do in your data warehouse. Hadoop can be used for large-scale searching, pre-processing type activities to extract interesting data that can then be analyzed in depth in your warehouse. So you can see some real benefits from combining these two environments. At a time when specialized tools and technologies have emerged to address the demand for advanced analytics, many companies are now dealing with a patchwork of disparate systems aimed at solving different analytics problems. And what it's important is to offer customers a high-performance analytics platform that breaks down these silos, making it possible to extend the power of big data analytics to users and business processes throughout the entire enterprise. The platform needs to combine data and analytics together for high performance. It's got to support different kinds of workloads, accessible to the entire community of users, and should integrate into the fabric of the enterprise's information systems and sources. First, any system dealing with big data has got to be able to scale out. One of the benefits of SAP Sybase IQ's shared everything architecture is that CPU and storage resources can be scaled incrementally and independently from each other, and you don't need to wheel in a whole new machine when you expand capacity. As an example of IQ's shared everything MPP architecture in use, one of SAP Sybase IQ's customers, ComScore, continuously captures massive amounts of web traffic data, analyzes consumers' online behavior, and aggregates the data for their marketing customers. ComScore utilizes a large SAP Sybase IQ, what we call a multiplex grid, to handle the multitude of concurrent users that access its system every day. ComScore manages more than 150 terabytes of data using tens of servers and hundreds of CPU cores. ComScore has incrementally scaled its multiplex on commodity hardware as its business has grown. A big data analytics platform must not only scale, it must support a diverse community of users. Another feature of IQ's shared everything grid architecture is logical servers. A logical server is a grouping of physical nodes in a multiplex. When a query is executing on a machine in a logical server, only the nodes within that particular logical server will participate in the query. This allows workloads to be isolated from each other for security or resource balancing purposes. A logical server can be used to build a virtual data mart, a set of storage and compute resources used for a particular purpose within an enterprise. The data mart is virtual because the set of storage and compute resources are part of a larger set, and the boundary around the mart is dynamic. Data can be moved to other areas of storage, and physical servers can migrate among logical servers. A data platform is only as good as the data, so fast data loading is paramount to ensure that your analytics are operating on the most current data. Sybase IQ's multiplex can accommodate parallel loads from multiple writer machines. And readers can continue reading data without waiting, even while writers are changing it. And when a reader joins the system, a snapshot of the current committed state of the database is taken, and the reader sees that snapshot version of the data until it completes its work. And writers create new versions without blocking the readers. And when dealing with big data, you do not want any machine resources sitting idle or underutilized. There's just too much work to be done. A query running in IQ in a multiplex can take advantage of all the memory and CPU resources across the grid. SAP Sybase IQ can take an individual query, break it up into independent fragments, and execute those fragments in parallel on multiple machines. The node that a query is initiated on is called the leader, and other nodes are the workers. Any node can be a leader at any time. It depends on how the client connects to the logical server. And leaders and workers can work on multiple queries at the same time. You can see that we're really taking advantage of all the computing resources that are on the grid in a very efficient way. We know that another aspect of big data is variety. And we've heard the estimate many times that 80% of all data is unstructured. Well, Sybase IQ helps you analyze unstructured data with its native full text search capability. IQ can store large clods or character large objects, can index them, and perform neighborhood searches on terms, Boolean searches. You can create expressions with ands and ors, and you can do fuzzy searches to find even misspelled terms, and you can do scoring to find the best match. This gives you a great tool in your toolbox for dealing with unstructured data. Traditional complex analytics have in the past involved moving data out of the database into specialized, often proprietary environments. This involves a time-consuming process of moving data in and out of the database, and sometimes into a proprietary platform that's not very accessible. With big data, this can be prohibitive because you've got just too much data to move back and forth. A better approach is to embed the analytics functions into the database itself. This is what we've done with SAP Sybase IQ. This performs a lot better because data does not have to be moved. All the data and results are shareable through the database access path, and they're easy to acquire via the familiar SQL interface. This allows the average developer to build in-database analytic models because he doesn't have to learn a new language or work in a different environment than the familiar DBMS. Certainly you need to have programmers around to build that programmatic logic, but once that's built and shareable, it's invocable from SQL. And when you talk about big data, you talk about Hadoop. And beyond all these capabilities I've mentioned where IQ is handling complex analytics on its own, it also offers 4 methods for integrating with Hadoop. And each is appropriate for a different kind of use case. And the first we call client-side federation. And SAP Sybase has partnered with the company Quest, which builds the Toad data management tool, very popular tool. And they've instrumented it in such a way that they can join pre-computed results from Hadoop and pre-computed results from IQ together in a SQL result set. And one place you might apply this might be a telco, where you're aggregating data from different domains to find a relationship between customer loyalty and network utilization. And the next type of integration we provide is ETL. Now here subsets of data from the Hadoop file system are transferred into IQ. And we've partnered with Cloudera to augment their ETL tool called Scoop to work with Sybase IQ. Now, use case here where you could have Hadoop used to filter a large set of data into a smaller set for deeper analysis inside IQ. Note that SAP Business Objects data services can also pull data from Hadoop into IQ as well as other database platforms. The third type of integration is we call data federation. And using IQ's extensibility framework, this is our user-defined function layer. You can, for plugging custom functions into the database, you can create a user-defined function that presents an HDFS file, or really any type of file, to IQ as an in-memory table. And this data is not moved persistently into the IQ store, but it can be accessed like any other table. And this allows large data sets to be stored in Hadoop, but analyzed quickly in IQ. And the use case is similar to the previous one with ETL, but an alternative when you don't really need to persist the Hadoop data for later use. A retail use case might be for IQ to fetch point-of-sale data at fixed intervals from Hadoop file systems on specific, maybe hot-selling items, and combining it with inventory data in IQ to predict and prevent inventory stockouts. And then the final way is query federation. And this is really similar to data federation, where we're using the user-defined function interface for plugging in custom functions into IQ. And that function will invoke a MapReduce job in Hadoop. And the UDF is now not presenting a Hadoop file to IQ as a table, but the result of a MapReduce job as a table. So this you might use instead of data federation when the data is changing more rapidly and you really need to rerun that MapReduce job to get the most recent data. So these different integration methods give the user a wide variety of choices when combining the power of your data warehouse in IQ with the power of Hadoop. Now, SAP Sybase IQ also offers what we call native MapReduce capability. Now, this allows you to perform massively distributed processing on big data without Hadoop. We have our multiplex grid architecture we have our ability to distribute queries and parallelize them. This is very similar to what MapReduce does. And compared to that, IQ breaks the big data problem into smaller independent pieces for parallel execution. And both Hadoop and IQ work on disjoint sets of data, and they can nest functions into a multi-level execution. Each has a master controller that reduces the results and ensures that all jobs complete. And in the case of native MapReduce with IQ, you can see that you're invoking these mapper and reducer functions from a SQL statement. You notice the partition by clauses to get those disjoint sets. And IQ, because it really can efficiently control all the resources that are available in the IQ cluster, operates more efficiently than a Hadoop cluster because it's controlling all the memory and CPU use. So that's where we are with our latest release of IQ that's in the market, Sybase IQ 15.4. We have all those features that I was talking about that are pertinent for big data analytics. But IQ never really stops innovating. We've had several releases over the last 3 years, all chock full of functions, and we currently have another one in development that is probably our biggest release in a long time with a lot of new capabilities. So I wanted to just give you a brief preview of that. You've probably heard the term in the news now that petabyte is the new terabyte. Big data never stops ballooning in size. And as databases grow from terabyte to petabyte size, new innovations are required. And SAP is making some radical improvements in its storage architecture, its loading engine, query processing, system reliability. IQ has enhanced its storage architecture for increased data compression, which is critical for big data volume. Its multiplex grid architectures become more resilient. This is very important for non-interruption of big data analytics. And the loading engine is faster than ever with fully parallelized execution. And the query engine intelligently caches data so the data stays resident in memory without requiring retrieval from storage. So your shared everything architecture starts to look a little bit more like a shared nothing architecture and getting some of those benefits, but still retaining the benefits of our shared everything approach. So in summary, Sybase IQ is a comprehensive platform for big data analytics. You can see our abstracted 3-tier architecture here at the bottom with the most mature column store in the business, our ability to do information lifecycle management across tiered storage, our massively parallel processed queries with virtual data marts, our loading engine, structured and unstructured data both managed and indexed for efficient access. That's at our data foundation layer. Above that, we have our application services layer with rich SQL, built-in full text search for that unstructured data, in database analytics to extend the capability of the database and reach out into big data platforms such as Hadoop. We also have database drivers, so from Web 2.0 programming environments, you can access IQ. And then at the top layer, we have many partners. We have a rich partner program at Sybase, now SAP, and across different types of solutions and tools and libraries. We've worked very effectively to have our partners create really fast, high-performing solutions that their customers depend on. So that's my presentation for today. And Eric, I'd like to hand back to you at this point.
Okay, and I'll hand the keys over to Robin. And Robin, if you just click anywhere on that slide and use the down arrow on your keyboard, one more, and there you go. The floor is yours.
Okay, thanks for the floor. I thought I'd start talking about the universe of big data, basically, just to try and position what I think big data is, to be honest. And my personal view is it's actually not that clear, in the sense that, and I think I can go to the next slide here, is that big data has really become a marketing term. And as such, it's as big a trend as cloud computing. And in my way of looking at things, you measure that by column inches. In other words, if people are writing stories in the newspapers about big data, and they are, then that's gathered so much attention that people who will never properly understand the field are actually reading about it and thinking something is going on. And of course something is going on. But the question is really what's going on. So I kind of did this. In about 2004, I produced a blog posting that says database size multiplies by a factor of 1,000 every 6 years. And that actually reduces to a data growth rate of about 55%. And data has been growing at 55% for well over 20 years. And at the same time, VLDBs have been growing at the same rate. In other words, the growth in the volume of the largest databases is no more than the full growth of corporate data anyway. There's no significant difference between the two. However, it is exponential. And because of that, there's nothing new really about big data in the sense of its actual size. You know, the thing that one wrestles with obviously is the size that the big databases have got to now, but there's nothing new. We always had VLDB. I used to attend VLDB conferences in the 1990s. In those days, they used to be scared of terabytes, and nowadays, well, I've got a terabyte on my Apple PC, Apple Mac. A terabyte's not a big thing. It actually is if it's a database, because there are problems in handling a terabyte database. But, you know, in terms of people's perception of size, terabyte not very big. We hit petabytes about 2010. If this trend increases, we'll have exabyte databases by 2016. I mean, it's that predictable. And I think in the article I wrote in 2004, I was saying we'll have petabyte databases by 2010. And, you know, not just one, because there may always be some, you know, really outlandish, on the bleeding edge type of project going on somewhere, but, you know, many, and we have many. So what's new? I attended an IBM presentation last week, and they came out with volume, velocity, variety, and verifiability. And my thought as I was sitting there is, if it doesn't begin with a V, it doesn't apply to big data. So, you know, there are things that maybe we should be concerned about with big data, like governance, but if you can't think of a word that begins with V, then it doesn't get in. In other words, I don't really like that. I think it's also the case that the implication by trotting these things out, these words out, is that all of these are happening to you at once. And in actual fact, there are probably no products that could take, you know, variety and really high velocity ingest and really large volume at the same time. You know, I mean, it's probably not the case. But one of those dimensions you probably can take. Well, actually, you do take with a lot of the big database products that exist. So the question really is, what really is new? Hadoop is new. Hadoop has become incredibly popular, and I think I've got stats that suggest that over 80% of the Fortune 500 have got a Hadoop project of some sort or other in progress right now. And I think what happened with Hadoop was that we never previously had a data store that you could just drop lots of stuff into. And Hadoop, which is really not well engineered to be anything like a database, because it takes batch jobs one at a time, and databases don't do that. They share amongst multiple users. But it's a really useful place to drop data, especially if you don't intend to keep it. You know, which actually raises the question about governance, because an awful lot of people, it seems to me, an awful lot of companies are actually taking on data, and they haven't decided what the actual life cycle of that data is. But that's another thing to talk about some other time. Big data in the cloud is new, and the reality of that is that you can configure and have available to you a very large amount, when you're going to pay for it, but it'll be a very large amount of computer hardware in the cloud, and you can load it up with data. And you can do that very, very swiftly. So, you know, a time any time to value that you had in mind has kind of really diminished. And previously, when people did very large database projects, they often spent an awful lot of time before the data was ever loaded trying to get anything right. With Hadoop, you can just drop it in there because it doesn't expect to be particularly right. You've only got to decide on what a key is, and after that, you just drop the stuff in. And I'm going to speak about this on the next slide, but there is what I think of as a new dynamic in data analytics. In other words, a kind of new way of doing things, not entirely new, but we didn't do that before, and it depends upon Hadoop. And the other thing that's worth mentioning is that volume and velocity nowadays is mostly about events. In other words, previously, and it's still the case, you can get an awful lot of data from, rolling up a lot of transactions. You could say, for instance, that a single telephone call on a telephone network is a transaction because you pay for it. And there are, huge volumes of those, so large that for many years the telco companies simply couldn't deal with them, but now they can. And they were transactions, and some of the what you would call big data heaps also consist of transactions, but we're now getting this flow of events that are not transactions, and I think that big data will be dominated by event data fairly soon. In a few years, what you'll be seeing is all the power companies will be capturing every single event that happens in your household that they can know about, so in one way or another they can tailor their services towards. And all of the what I would call public utilities are going to be doing the same thing. They're going to be instrumenting the whole of their environments in order to be able to do what they do better. And because of that, the world of embedded processes is going to expand the number of events worth processing, and that is the next revolution. You can think of there having been like a PC revolution that distributed power to individual users, and then a mobile revolution that distributed computer power to people wherever they were. Well, the next thing is the world of things is going to get instrumented. And that's just not going to stop because there's obvious money in it, and you can see that by the growth in our RFID, which is only a very small part of embedded processors. Okay, what I call the analytics two-step. This seems to be what I'm encountering in talking to users that are actually dealing with what I would reasonably but I would be reasonably willing to qualify as big data. In other words, heaps that are, in the 100 terabyte level. And basically, they have a big data heap. They do some analytics over that data in order to find useful relationships, useful trends, whatever. They are, in fact, mining the data on the big heap. But there's a two-step to this, which is having found a really useful relationship that's good for the business, they then tend to ETL the product through a data feed into an analytic database, and they pass it off to business staff that can use the knowledge discovered. And there may be some nuances to this in the sense that data feeds may be going into the big data heap all the time, and when you draw stuff off, you might want to actually capture some of those data feeds and draw them off. And you might want it to be aggregating things within the box that I've called ETL there as well in order to feed the analytical DBMS. But this is kind of new in my way of thinking, in the sense that most analytics that I ever saw going on before were possibly over a data warehouse or something, and might have resulted in the creation of a data mart that's kind of similar to this, but they were never posing huge queries on huge heaps of data. And that's the thing that's happened. The thing is we can assemble vast amounts of data now inexpensively enough to do some very, record by record analytics on them and discover things we could have never discovered before because we could never capture that data before. That simple, really. So that's what I would regard as something that's new. the next slide, which I think is the last slide, which is what's the future? I see no reason why this data growth trend won't continue. It will continue until we've run out of organizations that can capture that much data, and I don't see that stuff stopping anytime soon. There are lots and lots of examples of where people are rolling up petabytes in days now, so we are going to exabytes, and we will probably go on to zettabytes, whatever comes after exabytes. I can see that happening. But because the technology is getting refined, more and more companies are going to get drawn into using big data technologies in one way or another. It makes a lot of sense, and actually, I think Courtney has given the argument for that in terms of surveys of people getting great value out of doing analytics on large heaps of data. Question is, well, will a two-step become a one-step? And I'm not really sure about this. I'm not really sure about the destiny of Hadoop. Certainly, the database architectures that exist right now can scale out. So I'm going to ask Courtney about this, of course, but they could scale out probably to capture the big data heaps that Hadoop is capturing. There's nothing miraculous about what Hadoop is doing. It's just writing the stuff away to disk in a reasonably comprehensible way. But there's also the fact that the databases are kind of very precious about how they use their resources, and you really don't want an awful lot of data that you only need to look at once or twice, flushing up the database and interfering with all the other things that are going on in it. So I'm not sure whether this two-step becomes a one-step. May do, may not. In my opinion, just final point, I think that the RDBMS column store is going to remain as the big analytics engine, and that's just, it does that stuff very well. And it's now, and Sybase is demonstrating this, that they haven't stopped innovating. Most of the other vendors they compete with haven't stopped innovating. And these products are getting more and more capable, so I don't see them being overtaken by some other database from somewhere else that was, I don't know, based on NoSQL perhaps. I see that the RDMS is likely to be the analytics engine of the future. But that's just my opinion, and you don't have to believe me at all. So, questions for Courtney. The thing, I mean, I know your Sybase's answer to this, but I thought I'd ask it for the audience that don't really. You'll meet a lot of vendors that start to emphasize the fact that they've got a shared nothing architecture. Sybase IQ is definitely not a shared nothing architecture. It's a shared some things or shared everything to some degree architecture. So I would just like you to try and explain, if you will, why having a shared everything architecture isn't necessarily a disadvantage in terms of scalability.
Oh, thanks for that question. We went down this path because we saw some disadvantages to the shared nothing architecture. For one thing, the shared nothing architecture is designed to have every machine operate independently, and they don't have to share results. But when you add or remove nodes, you have to redistribute your data. When data changes, you have to redistribute your data. And this can be an expensive proposition. Another thing is, with IQ, you can size your data and your compute power separately. You can, if you need more storage, you can add storage. If you need more compute power, you can add more cores. But with the shared nothings, you tend to have to wheel in a whole new machine with more storage, more CPU. This gives us a more granular way to scale, and it's more cost-effective for our customers. And another thing with when you're spreading data among all the nodes, it's hard to isolate workloads to specific nodes. This is our logical server concept, where you can isolate a workload to a particular set of machines, but then those workloads can access any of the data that is in the shared store. So we can isolate these workloads across CPUs, but not prevent them from accessing the data that they need to access. So those are some of the reasons that we went down that path. And with our data affinity feature that's coming in the next release, which gives that shared everything a little more shared nothing, give some of the advantages of being able to have the data near the nodes that are doing the processing. So, you know, we kind of have the best of both worlds coming up in our next release.
Okay, and just as you obviously can't do this in any kind of accurate way, but just when you're actually sharing everything and you're doing it efficiently, because that's a trick, obviously. I mean, if you shared everything and you started having queues building up everywhere, then the performance would be poor. But I understand the Sybase architecture, but I'm kind of interested in, roughly speaking, in terms of the amount of servers that you would use for a similar size of data volume, how much less in terms of, you know, server boards do you actually use with this architecture?
I don't know that we would. What we are striving for is to use the server nodes and storage at the most efficient level possible. So if you got more users, we want to be able to distribute those queries across those different machines and make maximum use of the resources across the grid. So we're looking to achieve, you know, the most efficient utilization. And as you add users, you can add resources to accommodate them. But we don't want bottlenecks. We don't want underutilized CPU or memory. You want to be able to use everything you've got as it's the maximum amount possible.
Okay, I understand. You can't really answer me because workloads are so different one thing to another. So I think that's fair. In your presentation, it was just something that I noted down. You talked about real-time loading into a Delta store, right? I'd just like you to explain that quite simply because I didn't understand, maybe because you skipped over it, but I didn't understand exactly what that meant. So this is just, I didn't catch it. So if you did explain it, can you explain it again?
Well, this is something that's coming out in our next release of our product. And historically, IQ's been optimized for readers and for complex queries. So we can bring large amounts of data into memory and do very complex queries, and we do it efficiently because each I/O grabs a whole bunch of data. Now, on the right side, we're very efficient when it comes to bulk loading. If you load 1 million rows, we can do that very efficiently. We write large page sizes to disk. But if you're just writing a row here on a smaller scale, maybe you're doing really fast ingest and you're doing many rows at a time, but you're not necessarily batching them up. We don't do such a good job with that because every write might need to, write a couple of large size pages out to disk. So we're augmenting the IQ store with a Delta store that's write optimized, that has minimal indexing and compression, that's row locking instead of table locking, that's designed for fast concurrent writes to the same table by multiple writers. And then that is all hidden behind a consistency view so that as a client, you don't really know what data is where. You still operate with the database as you always have. But what we're trying to augment IQ with is that it's been a great read optimized engine and bulk write optimized engine, but now we want it to be able to handle low latency, very high frequency writes to smaller amounts of data. Okay,
well I can see where you're going. I'll be interested to have a more detailed explanation of that when it appears. Okay, I talked about this two-step process of analytics that I've seen in Hadoop implementations. You put together a reasonably muscly database and you have Hadoop kind of feeding it, but the analytics is tending to be going on to Hadoop. Are you noticing the same kind of thing?
With individuals being able to have to look at both kinds of processing environments, you mean?
Well, just there's a fair amount of analytics actually taking place on Hadoop itself, but only as a discovery thing. And after that, you shift it to an engine where people can share the resource because, of course, Hadoop is a batch engine. You can't share it.
Yeah, we're definitely seeing the combination of those environments with your analytics engine, that people aren't doing everything in Hadoop, and that, as you said, these column store databases are really well tuned for sophisticated kind of queries, and you're running sophisticated kind of queries. Hadoop is really good for very extensive but more simple kinds of algorithms where they don't have to share results. But it's great at going through massive amounts of data and combing through and finding the interesting bits, and then bringing those into the database for more in-depth analysis. Yes, we are definitely seeing that trend.
Okay, and you talked about doing these kind of joint queries and between Sybase IQ and between Hadoop. Can you give me a kind of use case that just explains where you would be likely to do that?
There are lots of different kinds of use cases. We have our 4 integration methods, so you might use a different approach in different cases. The data federation approach here is an example where you might have this retail use case where you're fetching point-of-sale data and looking for hot selling data and comparing it with your inventory data in IQ. But you really don't need to keep that data in IQ. It's fine to leave it in Hadoop and just do the combination joins to find the comparable where the intersection is. And then query federation, an example of that might be in the utilities industry, you might be running a Hadoop job to perform some computations on grid transmission quality data. And then you could join that with smart meter data that you've stored in IQ to analyze workload. So there are different kinds of examples where in these federation cases you really don't need to keep the data in IQ. You may not, as you mentioned before, you may only be using it once or you only for one purpose.
Yeah, right.
So these federation methods make a lot of sense.
Right, I kind of get where you're going, but you kind of have to synchronize your Hadoop activities with what you're doing on Sybase IQ so that everything's teed up to work together. That was the only thought that I had about that, but I presume that that's, if customers are doing it, then they've got that squared away.
Right. Well, that SQL command, controls, what it gets executed when and brings the results back in an aggregated result. So
yeah, right. So you basically got you've got the commands to do it, basically. I'm kind of interested to know, you may not even know the answer, but I'd be interested in even a guess, is roughly how many of your customers are actually using Hadoop? And I mean using Hadoop and also using Sybase IQ, obviously.
Well, we have over 2,000 customers, about 4,500 or so installations of IQ in various projects among those 2,000 customers. And we've seen probably around 10% are experimenting with Hadoop and IQ together. And then we actually have a few that are moving into production with some combined big data and data warehouse analysis going on together.
Right.
So it's still in the early stages.
Yeah, right. So I'm kind of, and again, I guess this question's a little bit ahead of time anyway, but I'm kind of interested in this is that, like, you guys are obviously at in your customer base called in to give your opinion about stuff. So are there situations where you'd walk in and recommend certain activities be done in Hadoop? Because my opinion is that pretty much anything Hadoop can do to the kind of data that Sybase IQ is good at handling, Sybase IQ could do anyway. So, I'm kind of interested as to where you might advise the use of Hadoop and where you would actually say to the customer, you should really put it in IQ.
I think some of the nature of it's like breadth versus depth, in my opinion. Hadoop is great with breadth stuff, but the algorithms tend to be fairly simple. I mean, if you look at the example Hadoop word count job, what it's doing is just simply summing up numbers, very simply, but it's trolling through just a ton of data really fast. But where you see IQ doing some, complicated joins and invocations of mathematical and statistical functions where you might be needing to, have correlated subqueries and keeping sharing data. You know, when you're getting really in depth and complex, I think that's where you need to throw a good column store analytic engine at it.
Yeah, of course. Okay, I'm just going to have one last question because I need to pass you or throw you to the lines in the audience in a minute. But I would like you to make some kind of give us some kind of view of how Sybase IQ fits with HANA. I personally have had a HANA presentation in the past week or two, and it's very impressive in-memory database that can actually scale a bit. So if you could just position, if you assume that, you know, a customer is very happy to buy HANA and deploy it, and also to buy Sybase IQ and deploy it, how do these two things fit together?
Okay. Well, we have a couple of use cases off the bat that I can talk about. One is that you would use HANA for your analytics for your most recent data, for your hot data, and you'd use IQ as a nearline store. When you're up into the hundreds of terabytes and petabytes level of data, and data changes its value as it ages, to have IQ sitting there as your nearline store, but still with very fast access and still having your data online while your really, really low latency queries and analytics are going on inside HANA, that's a great partnership for the two products. And then another example is that IQ would really be primarily your enterprise data warehouse, and that you might build these agile data marts, extracting data from that warehouse into a data mart that is in HANA. So there's a couple of examples right there where they complement each other very nicely, and that's a couple of ways we've seen it being used.
Yeah, okay. I mean, I know you can't say a whole heap because HANA's really fairly new in terms of it's being put out there, and you probably only have a small handful of sites. But anyway, I shall pass you back to Eric now because I'm sure the audience would like to speak to you.
Well, we have a lot of great questions already, so thank you so much, all of you who have sent them in. So, Courtney, let's see, I'll just kind of start at the top here, first come, first served kind of thing. Here's an interesting question from one of the audience members. When big data is involved using many of today's new tools, from Cognos to Tableau, how often does a data scientist need to be involved versus just an end user or knowledge worker for sort of operational BI style analytics?
That's a great question. There are some companies out there. One of our partners is KXEN, and they build an analytics workbench that's wizard-driven, and it's built for the business user. So it leads you through a set of questions and answers to define a particular analytic problem that you're interested in, and it's usually fairly narrowly targeted towards a marketing campaign. And underneath it all, behind the scenes, there were a lot of data scientists building all this intelligence into that product to make that available to someone with not the heavy math background. So I think you obviously have to have really in-depth mathematical and statistical capabilities in your staff to build some of these models. But you can, with the right packaging, and you can bring those forward to your business users so it's more available to the everyday person.
That's a good answer. And we actually took a briefing from KXEN a few weeks ago, maybe a couple of months now, and I have to agree, I think they have done as good a job, if not better, than anybody else at creating a very user-friendly, business user-friendly environment for doing predictive analytics and data mining, because let's face it, under the covers, that's some very, very complicated stuff. But I was really impressed at how good a job they did at really simplifying the workflow and the management environment for dealing with that stuff. So that's a good answer. Okay, so let's see. What about one of the attendees is asking, can you talk about versioning at all? What kind of versioning capabilities do you have in here?
Are we talking about the snapshot versioning for readers and writers, both accessing the database at the same time?
I think so, yeah.
Okay. This is a technique to allow database queries and database updates to occur at the same time without blocking each other. And this is not only done in IQ. This is done in other databases as well. But what happens is that when a reader comes into the system and begins a transaction, they get a snapshot, like a camera took a picture of the database. And that's the version that they see. It's consistent. It's the last committed set of data. And they see that version until they commit or disconnect. And then when they reconnect or start a new transaction, they will then see the next set of committed data that happened while they were doing their previous transaction. This is called versioning, snapshot versioning. And it's important in an analytics type, in a big data analytics platform, that nobody has to wait. That queries can occur while where loads are happening, and so this is the way that we accomplish that.
Okay. Good. And here's another. This is a lovely question that came in a few minutes ago, and it's a classic, obvious sort of question, but it's one that I'm not sure I've heard anyone answer recently. And obviously, it depends upon the environment, the use case, and how you want to do this stuff. But the question is, where is Hadoop data stored?
Hadoop data is stored at the very bottom level in the Hadoop file system, which is a very robust file system with redundancy built in. And then the Hadoop world is composed of many, many different tools and components. And there are other aspects of Hadoop, such as HBase, which is a database layer on top of the Hadoop file system that makes it look more like a database. So, down at the bottom level, you've got a very stable and robust file system. And above that, other kinds of tools and components are layered on top of it. But that's at the base where the data is stored.
Gotcha. Okay, good. And so here's an interesting question. It's, again, another fairly generic question, but it's a good one. How do you model information for big data use cases? And obviously, one of the things about big data is you don't need a schema. But can you talk about quickly how you would, and maybe I'll throw a second question in on that. There was someone who wanted to know about doing joins between structured and unstructured data. I know you talked about that for a minute, but can you talk about how you prepare big data and then how you would do joins between structured and unstructured?
Okay. Well, at the very minimum, if you're reading a Hadoop file, a Hadoop file system file, you have to know, how many fields you're reading, how many different pieces of data are in what we might call a row, and you've got to express that when you're building a function that reads that data from Hadoop and brings it into IQ as a table. So at the very minimum, you have to know what data types and how many pieces of data. Some of the pieces may be missing, but generally what you're going to be extracting as you read this Hadoop file system. So at the minimum amount, you've got to do that. We don't, IQ at this point, it's kind of a manual process to express that, although SAP Business Objects is starting to build some metadata around that, around Hadoop. So at the very minimum, you at least have to express, the structure of what you're reading in from the file system.
Mm-hmm. Okay, good. And a bunch of good questions here. I'm going to jump around a little bit. One of the attendees writes, when I think of processing big data, I think of data mining. It sounds like Hadoop is really just a file staging distributed processing technology. Is that a fair assessment?
It's definitely a way to store a lot of data in some kind of understandable way. It's built to work with this MapReduce type logic that can divide up the work and divide up the data into disjoint sets. I don't know if Robin wants to kind of chime in on aspects of Hadoop.
Yeah, Robin, you want to chime in real quick?
I can if you want. Well, I mean, the problem with Hadoop, if you like, is that it's got so many components you can put on top of it that it can do a lot of things for you. In other words, It's got a set of analytical capabilities. You can use the language R on it and so on and so forth. But it is constrained by the fact that it's batch. It's not multi-user. So whatever you're doing, you're scheduling. And because you're scheduling it, you can't treat it per se as a database in the way that you would normally treat a database. But there are a lot of things that people have done with it that are even outside the bounds of normal database. Like people have used it for parallel processing for rendering 3D images and things like that, simply because the MapReduce algorithm is very, very good at distributing workloads.
Mm-hmm. No, that's a very good question. And another one of the questions that just came in here, it again, I think speaks to how people are trying to wrap their heads around how you merge these worlds. And the bottom line is that it takes a lot of thought. I mean, it really takes a lot of intuition, but also just mental human processing to know which types of big data to mine in which ways, and then ultimately couple with your structured data. So the question, just to read it verbatim here, is in the slide it shows that big data environment there is no schema. If that's the case, then how do we approach the set of analytical questions within an enterprise or even a given business segment within an enterprise? I think that's basically what he's asking is, how am I supposed to mesh these environments if there's no schema on that unstructured side?
Well, I mean, it's not like you don't know what you've stored in the Hadoop file system. For example, you're doing weblog processing, so all the data is going to look like weblogs, or you're doing clickstreams, or you're doing some kind of graphical processing. I mean, the data doesn't have a create table statement associated with it, but I mean, you know what's in there. It's not a complete amorphous blob. It's designed to be input very quickly without some of the nice relational structures that the database have, but there's still some semantics and meaning around it. And when you read data from a Hadoop file, I mean, you can put some structure on top of it. For example, if you run, I'm going back to this little word count example, but the word count example brings back 2 columns, essentially, of data. It brings back a word and the number of times it appears in all the different files that you had it search. So there's some structure there. And you can express that to a database like IQ as what looks like a 2-column table. And you can create a user-defined function that reads that data, and we have the infrastructure around to present that so it looks exactly like you would define the DDL for a 2-column table. So it's not really quite as extreme as it sounds, that it's just a whole bunch of blob of amorphous data. There is meaning and semantics and some kind of structure to it, and you can express that in such a way as to bring back some meaningful data that you can join with a true table in your database.
Right, and a lot of this is going to be sort of an iterative process, I have to think. In other words, you're going to look at your big data, you're going to mine it, you're going to look for certain patterns in the data, and then you're going to figure out how you can use this contextual information to get better answers from that more traditional structured world of data. Is that a fair assessment?
Right. Yeah, I think that's a good way to describe it.
Okay. All right. Well, let's see. So one last question here. One of the attendees clarified something, saying, well, what I'm asking is that once the data is loaded into Hive after MapReduce execution, this data needs to be loaded in a system that can process complicated and analytical queries on multi-terabytes of data. For that, I assume Sybase IQ is the solution. Right,
and like Robin was saying earlier, you may not be interested in all of that data. You're probably going to be picking and choosing, looking for car reviews of the particular automobile that you are manufacturing rather than every single car that's been manufactured ever. So you may be doing some data mining, some pulling the pertinent data that's going to be of interest to you. You may federate it because you're going to get a new batch of data. Or you might say, hey, that data looks pretty good. I'm interested in it, and it's going to be valuable for a while, and I'm going to use it for different purposes. I'm going to ETL it and bring it right into the database. So that's why we provide these different kind of integration methods, because we can't guess in all cases what's the best method, and we want to provide you with several ways for making use of big data.
Okay, good. Well, folks, we've gone a little bit over time here, so big thank you to our presenters today, to Robin, of course, and to Courtney. You can see coming up the rest of this month is database. We've got a packed month. We're on a real streak here, folks. Next month is cloud. December is innovators. And January, it's right back to the world of big data once again. It is a very hot topic and it's going to remain so. We will pass on all these questions to our presenters today. So if you feel any question you asked was not answered, fear not. Somebody will get in touch with you. And we do archive all these webcasts for later viewing, so you can always check out InsideAnalysis.com, look under the webcasts section, look under the briefing room, and you can see both upcoming episodes and recent episodes. They're all archived. We also post slides there for your ease of use, so feel free to share it with your friends and colleagues. And with that, folks, we're going to end today's event. But once again, thank you so much for your time and attention, folks. We'll catch up to you next week when, once again, we're going to talk all about Hadoop, what it is and what it's not. We'll have my good friend Mark Madsen of Third Nature on hand to talk about all that, and Hortonworks, which you may have heard a lot about lately. So thanks again, folks. We'll catch up to you next week. Take care. Bye-bye.